Okay.
Thank you, sir.
Lokeshwari, we can exactly start by 6 Lokeshwari. I think students are allowing the members after checking. So we
Okay,
can
ma'am.
start exactly by 6. Sir has already come.
Yes, ma'am. Yes, ma'am.
Vishnupriya, are you ready?
Vishnupriya?
Yes, ma'am. Yes, ma'am.
Yes, ma, you can go ahead.
Okay.
Lokeshwari,
Every
we can
cloud has a
exactly
silver
start by
lining and
6
so does
Lokeshwari.
life.
I think students are
Keeping this thought
allowing
in
the
mind, let's
members
begin
after
today's
checking.
session.
So we
Myself,
Okay,
can
ma'am.
Vishnu
start
Priya M,
exactly by 6.
first year
Sir has
MBA,
already come.
take
Yes,
immense
ma'am.
pleasure
Yes,
in
ma'am.
welcoming you all virtually to this 5 days faculty development program themed Emerging
Vishnupriya, are
Trends
you
in
ready?
Technology and Management. The main
Vishnupriya?
idea behind this development program is to
Yes, ma,
help
you can go
faculty
ahead.
members, research scholars, and others to
Lokeshwari, we
strengthen,
can
enhance, and upgrade their teaching and research skills in the trending and emerging sectors of management. I sincerely welcome our Secretary, Sri Ashok Kumar Mundra, our Principal, Captain Dr. S. Santosh Babu, and our Director, Ma'am, Dr. U. Amaleshwari, and the participants to the second day of Faculty Development Program of DDGD Vaishnav School of Management. The research title for today is SPSS Cluster Analysis and Discriminant Analysis by our resource person Dr. Kasilingam. Dr. Kasilingam is a professor of finance, business analytics, and business law. He is a multi-talented person with n number of qualifications, right from MBA, MCA, ML, MPhil to PhD. He is one of the most sought resource person in India and abroad, and he is also present in the reviewer panel of many known international journals. He has also received awards like Global Excellence Award in the year 2022 from Special Minds India and Unifacvist University South America. He has organized 30 plus data analysis workshops, MDPs, and EDPs. He is also a member of numerous professional bodies like MMA, TIES, and he is also associated with Tata Consultancy Services for initiatives. We welcome you, sir.
Sir, it's a very great honor having you here for this session, sir. The session is all yours, sir. Thank you for joining us, sir.
Thank you, madam. Thank you for giving this opportunity to interact with people in the evening. Right nowadays, all the people they do the program only in the evening so that it will be most useful to many people after their academic activities. They can spend some time to learn. So now I will be introducing the SPSS. Right, SPSS are mainly for factor cluster discriminant analysis. So now the order normally we will go with some order that is called first we will start with factor, then based on factor we will go for cluster, then after cluster we will try to find out how it discriminates like that. So first, let me start with the factor. Okay, so now mainly for factor cluster discriminant analysis. So now the order normally we will go with some order that is called
I
first
have
we will
separate
start with factor,
folder for
then
every
based on
analysis.
factor we will
So
go for
okay,
cluster.
now I have to present.
Then
Right?
after
Let
cluster
me present.
find out how it discriminates like that. So first, let me start with the factor. Okay, so now mainly for factor cluster discriminant analysis. So now the order normally we will go with some order that is
So
called
I
first we
have
will start
separate
with factor,
folder for
then
every
based on
analysis.
factor we will
So
go for
okay,
cluster.
now I have to present.
Then
Right?
so first let me start with the my screen is visible to you.
Yes, sir.
Hello.
Yes, sir.
Yes, sir. Yes, sir.
Yeah, I'm audible.
Yes, sir. You are audible, sir.
I'm audible. Number one, number two, my screen also visible to you, right?
Yes, sir.
So now somebody should interact with me. Now, who can interact with me? Amaleswari madam or Loyeswari madam, or who will interact with me? I will
Yes,
be
sir.
continuous. Who,
Yes,
madam?
sir.
Logeshwari,
My
madam?
yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
Madam
sir.
will be available. Yes.
Okay. So now, what you can you see some word file, madam?
Yes, sir.
What is this, madam?
Questioner.
Yeah, it is a one questionnaire. So yeah, there is a big questionnaire. So one portion of the questionnaire I am showing you. Right. So this portion contains 19 statements. So all statements relating to factor considered or criteria considered when you make investment decision, right? Mainly it is for small saving instruments or tax saving instruments. So what are the factors you consider before choosing a particular investment avenue, right? Otherwise called factors considered or criteria considered. So for which 19 statements are given. 19 statements are given, right? So you can see the 19 statements. So now these 19 statements are right. So now what you see, madam? Now
The data entry, sir, in SPSS.
so this is a SPSS data set where I have entered these 19 statements, all 19 statements, whatever data collected. So that is collected in a 5-point scale. The first person has ticked 2 for the first statement and 3 for the second statement, 4 for the second statement, like that. So for 19 statements, what he has ticked, it is ended here. So like that, data is collected from 552 respondent. 552 respondent data is collected. So this is the data. This is the data. Now what you can do is, so whenever you have data like this, so you can do mean analysis, standard deviation analysis. So then if you want to find out whether the which kind of people preferring first criteria, you can do with okay, so on all these things. But when you do that, you will be having 19 statements. 19 statements. For each statement, you will be getting a mean. Right. You will be getting a
Dear participants, dear participants, kindly mute yourself.
right. So now you will be having 90. You are having 19 statements, right? So when you do, for example, you have taken age category. Age category as a categorical variable. Now you want to find out which age category prefer
Sorry
which
to interrupt,
criteria.
sir. Sorry to interrupt, sir. I kindly ask all the participants to just mute.
Lokeshwari, the admin can also mute everyone.
Sure, ma'am. Sure, ma'am.
Okay. So now, then what you will get is you will get 19 mean. So there will not be much difference in all the criteria, right? So you will be end up with confusion. So which age category prefer which criteria? So whenever you have this large data, you will be having a trouble. One is you will be having a trouble. Second one is the difference between one statement and another statement will be marginal. You cannot come to conclusion. So it is not advisable to have so many statements under one construct. So it is better to reduce into few things so that you can use any analysis very easily. For that purpose only we are going for the factor analysis. Otherwise we call it as EFA, exploratory factor analysis. Otherwise exploring, trying to find out is there any factors available inside, hidden. So what do you mean by factors? Now, some of these statements are related. Some of these statements, see, for example, some statement, all the people they might have, most of the people they might have given a similar responses. In such cases, there is no necessity to have so many. So all related statements can be grouped. right? So now we are going to group the related statements. So that is called the factor analysis, right? So you have 19. Out of that 19, there is a possibility to have some similar group of statements. So trying to find out group of similar statements is called the exploratory factor analysis. So this is done basically by using the correlation. Otherwise, statements which are related, we are going to group them. So whenever we say related, it is nothing but correlation. So whenever some items are closely correlated, that statements can be grouped, right? So first point is, this exploratory factor analysis is a dimension reduction analysis or data reduction technique. You have many and you are trying to reduce. So otherwise classification or grouping of similar variables or here similar statements, that is called a factor analysis. So first point we are going to do with the help of correlation, right? So first we need to judge, we need to know whether such related statements are available. When all statements are different, then you cannot group, right? So we need to find out whether there exists any relation among the statements. So first let me do, okay, whether they are related. So now I have, okay, so I have this one, right, 19 statements. So now I can do here, okay, so correlation by using this correlate, right? For example, let me use this correlate test. Okay, so I can select all, control A I have used. So I have pushed it to another box. So now I can use this correlation. Then I will get the correlation. You can see this is not, first statement is not related with the second statement. First statement is related with statement. First statement related with the fourth statement. First statement, how do I say? 0.000, okay, less than 0.05, which means they are related. So if it is more than 0.05, they are not related. Here it is more than 0.05, 0.109, more than 0.05, so not related. This is 0.00, which is less than 0.05, which means first statement, that is fact 5.1, that statement, and fact 5.3, they are related. Like the same fact 5.1 and fact 5 are related. So like this, I could see some relationship. That is the first one. So now I have done by using the correlation, but since we might be interested to do correlation, that is available under the factor analysis also. Same result you will get. So factor analysis is available under analyze, dimension reduction, factor, right? If I go here, factor, I can see. So now like the same, control A, and let me put it here in the descriptive statistics. So I can use the correlation matrix. So whether I want to get a significant value also or only coefficient, let me have both, then only I can understand. So continue, right? Here also I can use, right? Let me use, right? I will be getting the same result, right? So now let me look at, this is the correlation value. Let me look at the first statement, fact 5.1 is not related with the fact 5.2, and fact 5.1 related to fact 5.3, 5.4, 5.6, 5.7, 5.8, but not related with the 5.9. So like this, we could see. So first, this will not be reported, not necessary. But if you want to report this also, you can report there exists some relationship. So these statements can be grouped, that you can see. Okay, but it is not necessary, very much essential, not very much essential, right? So there is a correlation, right? So now I could see some items are related. Now I want to see overall, what is the position? Overall, okay, overall, what is the overall relationship among the items, right? So for which what I'm going to use whether overall there is a significant relation available. So that we call it as measures of sampling adequacy. Otherwise, that is measured with a KMO or Portlet test. Okay, two tests. So now dimension reduction factor, right? Factor. Now in the descriptives. So if I click, let me not have this one, right? Because already we have seen. Let us go to KMO, right? Kaiser, Mayer, sampling or length, right? Otherwise, that test of sphericity. So if I click this, then I will get, okay, I will get this table. So now the Kaiser, Mayer, Algin, right? Measures of sampling adequacy, MSA, measures of sampling adequacy. This is 0.873. So otherwise, we can call it as overall relationship. The overall relationship is 0.8. When the overall relationship is 0.5 or 0.6, it is sufficient. Now we have 0.837, which means our data is sufficient to perform factor analysis. So our data is suitable to perform factor analysis, right? So whenever we say, people used to say this is the measures for judging the sample size, but it is not the measures of determining the sample size. But we can say for the factor analysis whether the samples are adequate or not, that you can decide. But it is not about the sample size; it is about the correlation. Yeah, right? It is about the correlation. So whether we have a sufficient correlation among the data, that is what we are judging. So now there is a sufficient correlation, so which means sample is adequate to perform, or data is adequate to perform, or otherwise we can perform factor analysis for this data. That is number one. Number two, now this is a test, so we have a significant value. So null hypothesis is non-diagonal values, right? What do you mean by non-diagonal values? So diagonal values are relations between its own variable, right? Now if you look at this one, so we have seen the correlation, right? You have seen the correlation, right? So now these diagonals always it will be 1. So which means the relationship between phi 1 and phi 1, relations between phi 2, phi 2, right? If you look at it, so phi 1 and phi 1, 1, phi 2 is 1. So diagonals values will be relationship between its own. So definitely it will be 1. So all other, that is why all non-diagonal values we say null hypothesis means the correlation value we presume it is 0, which means no correlation. But the chi-square test says it is rejected. Portlet test says it is rejected, which means so we cannot say, okay, we cannot say the correlation is 0, right? Which means correlation is adequate. Correlation is adequate to perform the factor analysis. So that is the first one. That is the first one, right? Now, okay, now second one. Okay, now factor analysis is nothing but, right, grouping of statements. So we say 19, right? We are going to group. So the first question will be how many groups, right? How many groups you are going to have, right? Whether it is 2 groups or 3 groups or 4 groups, right? So now, right, now we have to decide the number of groups. Okay, so now how to perform, right? This one, dimension reduction factor, right? So extraction, right? We are going to the extraction, right? The extraction methods, there are many methods. So we are using principal component method. There are many methods are available. So principal component method is most popular. So that is the default one. We are using that. Okay, extracting variance from the data. Okay, so now let us continue and let us say okay. So now okay, now it says the 19 statements, right? 19 statements we have put. Okay, so total variance, if you put 19, right? If you put a 19 statement into 19 groups, so you will extract 100%, but now it says that it can be grouped into, it can be grouped into 4, it can be grouped into 4, right? So now it says that 19 can be grouped into 4 groups, right? It can be grouped into 4 groups. Now if you put it into 4 groups, right, if it is individual, right, it will represent fully. But if you put it in a group, it's a representation, right? It's a representation may not be there fully in a particular group. So it will go only to certain level into that particular group. It may not fit 100% into that particular group. It may fit into 60% or 70%. So some of the data is not extracted. So now how much is extracted? Now it is 55%. If you put only one group, it will extract 32%. If you put a second group, it will extract 9. So totally 42. If you put a 3, that third group alone 7, it will become 42. Fourth group is 6. If you put the fourth group, 4 groups, totally you can extract 55%. So total variance extracted, right? Sum of squares of loading. So sum of square loading is a variance extracted or information extracted. So squares, okay, of loading is 55%. So which means the 55% of the information is extracted when you put 4 groups, right? 4 groups. Okay, suppose if you feel okay, so now it is 55 is not sufficient, then you want to get more, then you have to increase the number of groups. So how to increase the number of groups? Now, right now, go to dimension reduction, go to factor, right, go to factor extraction, right. So now here you put it as of, okay, now we have 4. Now if you put 5, okay, it says fixed number of factors or factors to be extracted 5. Earlier we have used okay, so number of factors decided based on eigenvalue. Eigenvalue, what are all the factors for which eigenvalue greater than 1? Eigenvalue greater than 1 is extracted or used. Now we are ignoring that stuff. We say specific number of groups, so it will give, okay, so now you can see 5 groups, right? 5 groups, so it will become 60, right? So now this, see here, okay, so this is the eigenvalue extracted. So one is 6, so this is 1.8, this is 1.3, this is 1.1, so this is 1. Okay, so now what is this eigenvalue? All these things I will come, right? But first let me tell you, let me not go into any of the statistics. First let me tell you what you require, what you will be interested as a researcher or as a person you want to do the factor analysis. So first step is okay, you have to decide the number of factors that you can decide based on this empirical, right? That is I want to get more, so I'm using this one. Otherwise, okay, from the study, okay, you know that 4 factors or 5 factors are required based on literature. You can go to that also, that you can decide. Now, okay, now we have decided, okay, so okay, 5, how to increase 4 to 5, that I have shown. So now let me go back to 4. Let me go back to 4 dimension reduction. Okay, so 4, okay, extraction. So let me put this one, eigenvalue 1, right? So now it is 4. Now 4 groups. That is first step is over. Okay. Now the second step. What is the second step? Now we say that we have 4 groups, right? We have 4 groups, right? So what is factor analysis? Grouping, right? Now all 19 is grouped into 4. Fine. Now what is the second one? now you have 4 groups. Now we have to put each item into one particular group. Otherwise, we want to know which item is loaded into which group, or which item is placed under which group, right? So that is the second one. So now how to see that? So this will give the second output. So this is the output. Now, if you look at it, if you look at, these are all the loading. The first statement is loaded into, okay, first group, okay, one for 0.4. That is, if you put it into first one, it will load 40%. If you put it into, okay, 2, it will load 16%. If you put it into 3, it will load 49%, 0.49. If you put it into 4, it will load 0.153. So now where will you put it? You will be putting under 3. So otherwise we can say factor 1 or item 1 is loaded into the group 3 or factor 3. So second statement here loading is more, that is loaded into 4. First statement into 3, the second statement into 4, third statement into 1, and fourth into 1, and 5 into 3, and 6 into 4. Okay, so now you can decide. Now you can see where it is loaded more. So now see, it loads into 1, loads into 2 also, loads into 3 also, right? Right. So loads into 3 also, right? So now, right. Now it is loading into all this one. Now it is loading into all this one, right? So now, right, now, okay, now, so it is loading into all these things. It is loading into all these things. Now, okay, now you have, right, you have this 0.408, 0.1169. So the square and summation, right? So that is called communality. Right? That is called communality. So which means the factor 1, that is item 1 loaded into factor 1, factor 2, factor 3, and factor 4, right? So if you add, otherwise not simply add, a square and add, so you will get this 0.460. So the communality is total loading of that particular statement into all the 4 groups. So which means overall it is loaded only 0.46, which is not sufficient. It should be more. So the communality should be greater than 0.5. So which means then only each particular item is extracted fully. That is at least 50% we should extract. So the what is communality is each item, right? Each item loaded here, loaded here, loaded here, loaded here, right? The addition, right? It is not simple addition, square and added, right? Is the extract variance extracted. So it is square, right? Sum of squared. So square and sum, that is called communalities of for each statement. So now, okay, so now you can say when the communality is less than 5, which means that particular item is not properly extracted, right? So that is number 1. Right? Now let us come back to our ultimate another purpose. Now what happens is now here, right? So now if you place the fact item 1 to the factor 3, it is loaded 0.49, right? If you take the item 3, if you put it under taking only 45%, so if you place into 1, so not even 50% is extracted. So which means, okay, we are not happy. Most of the items are not properly extracted. So which means, so the present one is, we are not happy with the present one. Right. So we are not happy with the present loading. So number of factors, fine. Now each statement is, we are trying to place into each group, but when you place into first one to factor 3, we are extracting only 49% of that item. So which means we are extracting less.
So which means so items or whatever we have collected data, the information is not fully used. So which means we are wasting most of the information. So present one is not suitable. So what we are going to do is we are going to rotate. Or we are going to change by using orthogonal rotation, right? Orthogonal rotation. We are going to rotate. We are changing it, right? So we are changing it. So finally, we are trying to find out the suitable one. So now I'm going for rotation. So analyze, dimension reduction, factor, rotation, right? I'm going for rotation. So the popular rotation is Varimax rotation. Now you need to understand, right? So whenever we say factor, so it is extensively used by Kaiser, right? It is extensively used by Kaiser in his paper, right? You have to refer that paper. So you have to quote his paper. So now, that gentleman says Varimax rotation is most widely used, and he says that we are trying to extract maximum. By using this method, we are trying to extract the maximum variability of that particular statement, how it varies from others. So we are trying to extract. So variance, Varimax is the better rotation. Now we will say rotation, right? Now what will happen is same for, right? Now here what happens, right? All right. So now here, this is the original one. 33.97. Now after rotation, the first statement, first group is extracted 22, second 11, third 10, 10. So total will be same, right? Only we are changing, one item from one group to another group. So total extracted is same. Now each statement is placed in different one. So now, so the importance of first group, earlier 32, now it has come down. So now, all here, all other groups are different now. So now the second one, it is not necessary. We have to use this is a rotation sum of squared loading, right? What is that? Also very easy, right? Right. So now we should not use this commonality, this component matrix. Now we have one more matrix that is called rotated component matrix. So now you can see, right? First statement earlier it was under third. Now it is under 2. Now it is 6.646. So earlier the second statement was in 4. Now it is in 3. Earlier third is under 1. Now it is under 3. So completely changed. Now you can see each statement will be loading more than 50%, otherwise 0.5. So here 0.5, here 0.7, here 0.5, here 0.7, 0.7, right? 0.5. So like that 0.6, right? All these statements will be having more than 0.5. So we have to go for rotated, right? Now we have a rotated. Now, okay. So now what is this? The variance extracted. Now I will tell simple thing. Now later I will show, because here we have 19 statement. Explanation will be little tough. After some time I will be using limited number of statements so that I can tell easily. So what is this sum of squares of loading? So each group, right? This is the loading I am telling, right? So now this square, right? Add of all first. See, commonality for each item, right? So each item loaded into different groups, squared and adding. Now for one group, this is the loading of different statement, one group, right? So square and add, that is called the eigenvalue. That is called the eigenvalue. So now if you square and add, so if you square and add, right, square and add, then that is this, okay, that is this 4.326 eigenvalue. So that is the eigenvalue, right? That is the eigenvalue. So what is the eigenvalue? So we have a variance extracted, right? Square and add. If you add, you will get this 4, right? You will get this 4. Okay, so now for each one, right? Okay, so now okay, you will have, okay, eigenvalue. If you put all the 19, totally it will be 19. Totally it will be a 19, right? So which means the eigenvalue for all these things will be less than 1. So some will be more, because total 19 statement means the total eigenvalue of all the 19 is 19. But 1 is 4 means others will be definitely less, right? Because 91 each 19, so 1 is more than 1 means all will be 19. So that is why we are using whichever group having more than one eigenvalue is the better group, right? So that we will see, right? Now what you need to understand is, so this is nothing but, okay, squaring and adding of, okay, so these are all the statement loaded under, okay, this statement loaded here, squaring and adding for a particular group, that is called the eigenvalue. That is called the eigenvalue, right? So that eigenvalue divided by 19, that is the total. That is the 4 divided by 19, 4 divided by 9, 4 point, all right, 4.3 divided by 19 will give, okay, 22%. 2.2 divided by 19 will give 11%. Okay, so that is what the percentage of variance extracted, all right, into 100 equal to. So this one, right? So now you know what is rotated, right? So normally we will be using the rotated. Okay, so rotated, right?
Dear participants, kindly wait. I think Sir will join as soon as he recharges. Kindly wait. So far, if you have any queries, you can just post your questions in the chat box. Thank you.
Sorry, madam. Okay, so power of okay. So now, okay, so so now okay. So now let me perform again, right? Okay. So now analyze dimension reduction. So it is a reduction technique. Factor, right? Factor is nothing but grouping of similar statements, right? So now we have seen the rotation, right? Extraction, right? We have seen the rotation, that is the very max rotation we have used, right? Right. Right, we have seen. So we have seen this four groups, and okay, so these are all the one, right? This we have seen, right? So now here, okay, so instead of looking at it, instead of if you look at this rotated component matrix, right? Okay, so let me tell. These are all over. These are now factor analysis is over. So now, okay, some more options we have. Some more options for better understanding, better one. So, but you let us go to the option, right? Suppress, suppress. So there are many values, right? If any value, because we want to have okay, all should be greater than 0.5. Let us put absolute value above zero point 0.5. So suppress if you put right. So then now let us go to this. Okay, now we can see. Now we can see the statement one is loaded into group two. Statement two loaded into three. Statement three is loaded into. So which statement is loaded? Which group? It is very clear. Very clear, right? So now that is okay. Which okay that loaded into which group, that we can see very easily. Very it is visible, right? Clearly visible. Now what we will be interested is, so under first group, all right, all you put one, all put right, all statements which are grouped under first group, all statement grouped under two, all statement grouped under three, like that. If you put it, it will be better, right? Then okay, so how to do? Analyze. So now here this will be changed, not 5 1 5 2 that order.
we will be changed all statement under group 1, right? So now options, you go to sorting by size, right? Size of the loading, right? So now you can see, okay, these are all the statements loaded under group 1. Now, not only that, now 14th statement is loaded more into group 1. Though there are so many items, 2, 4, 6, 8, 9 items, among the 9 items, loading of 14th statement in the group 1 is more. So according to size of the loading, it is sorted. Now if you look at this one, right, okay, statement, okay, so these two under this one and not this one, right? I should have gone to rotated, sorry. Okay, sorry. Okay, so I should have gone to rotated, right? So statement 16 is highest loaded. So this is the group 2, this is the group 3, this is the group 4, right? You can see like this. So it will be attractive, quite attractive, right? Quite attractive. So this is okay, these are all the statement grouped under 1, these are all the statement grouped under 2, these are all the statement grouped under 3, these are all the statement grouped under 4, that one. Now apart from that, now okay, it is this is the highest loading here, this is the highest loading, this is the highest loading, right? So now what is more important is now you have grouped the items. Now you have to give some name to each factor. This is most important, right? You should give appropriate name which will represent all the items, or which will represent most of the items. So for this one, you require your subject knowledge, right? So this till this one, any statistician can do. Till this one, so any statistician they can do. But this naming, according to your subject knowledge, according to your research, you should give a appropriate name. Now, so if I look at any of the thesis, if the names are given by statistician, I will understand. So the way in which they have given the names, right? Just like that, they will give name. So that is not advisable. You should give a name which will represent all the items. Apart from that, that should be related to the subject. See, for example, here. Now look at the, okay, now let us look at these items 16, 19, 17, 18, right? Otherwise called 12, 13, 14, 15, 16, 17, 18, like that, right? From 12 to 19, right? 12 to 19. Okay, so that is what loaded, right? Now let me. Right. So now these are all the 8 statements from 12, 8 statements, right? Here let us go and see. Before component 9, now after rotation 8, 2, 4, 6, 8. So these statements are from 12 to 19, right? 12 to 19. So now if you look at this one, 8 statements. So now it is about the criteria. Right?
So when we choose any particular investment avenue, right, what criteria will you choose? So one, normally if you have some investment knowledge, we can say it is a risk and the return and the liquidity and the convenience, right? So now convenience means it is nearby available, it is easy to understand, right? All informations are publicly available, collecting information is easy. So these are all the convenience, now if you look at this one, so there is no hindrance in getting information, right? The place of investment is located this one, the agents are providing this one, right? Most of these statements are relating to convenience. So I will say factor one is convenience, right? So next is factor two. Okay, small savings gives the investor protection and there is no risk. So which means it is talking about the risk. So third is talking about, okay, so this is, okay, so return. Fourth one is talking about the liquidity, right? Okay, so now according to that is what I have told you, right? You have to read, right? You have to read and you have to use your subject knowledge to name. So this factor naming is very, very important, right? So now you are given, these are all the factor name: convenience, risk protection, return, and the liquidity. So these are all the names given. These are all the names given, right? Now, right? So now, see, what is our purpose? Our purpose is to, okay, we have 19 statements. 19 statements are very heavy to use, right? Now that is what we went for reduction. Now we have four. Right? So for future purpose, we have to use these four, right? Only these four. We will be using this one only whenever you perform any other analysis in future. So now we need to see if we are going to, we say we are not going to use this 19, right? So then you need to have variable, then only you can use, right? Here you should have some values. People, right? I've seen say around 150 theses I have evaluated. So now most of the people, they use factor analysis in the end. No, it is the beginning. You should perform in the beginning, right? So now you have collected a data, you have huge data, reducing the data before performing the analysis. Right. So now we are whenever you do any analysis, you have to use the reduced factor for our analysis. Right. So we need to have data for that four factors. How to get. So now analyze dimension reduction factor. So now we have used this descriptives, we have used this extraction, we have used this rotation, we have used this option. Now we have scores. Save the scores as a variable. Right. Right. So now if I go and see the data set, now I can see four new variables, right? So this is the factor 1, this is the factor 2, factor 3, factor 4. Right. So now, okay. Right. So now this is the factor score. This is the factor score. Now these scores are standardized scores. Right. These scores are standardized scores. Right. So what do you mean by standardized scores? Or why do we go for standardized scores? Okay. So before understanding that, okay, so if it is a standardized scores, what will be the property?
what will be the property, right? So the properties of standardized scores are the mean will be 0 and the variance will be 1, right? So that is this one. So mean will be 1. So now let us see. Okay, whether the, okay, so now let me perform a mean. For these variables. So you can see standard deviation is 1, right? See here, mean is 0, all the 4 mean is 0, standard deviation is 1, and variance is 1, which means these scores are standardized scores. These means are scores are standardized scores. So now you say when the mean is 0, average is 0. Right. So when the when it is okay, when it is plus, see, average is 0, right? Average is 0, right? So which means some values are above 0, some values are below 0. Add and divide, you will get to 0. So if any of the values are positives, which means, right, which means the loading of that variable, that is loaded into that item is loaded there, right? That item is loaded there. So we will try to understand further, right? So now we try to understand. So the mean is 0, right? Okay. So this is the score, right? Now we can use this one, right? Okay, suppose so that we will try to understand further, right? Okay, so now this is the one, right? Now, earlier we have seen the items are related. Now we have divided into groups, right? 4 groups. Now what will be the correlation between the groups? Now there should not be any relation. The factors should not be related. If the factors are related, right, what does it mean? There is no necessity to have 2 different factors. When this is and this one is same, what is the necessity to have different factors? So which means this item is loading here, loading there also, right? So loading there also, that is why the items are factors are related, right? So when you put it in one, you should not have any relation with the other one, right? So now, okay, so now let me tell here one important point that we will be using throughout. Okay, next when we do Thursday also we will be using this one. Now point number 1, so when you put some items into the factor, the item should be related with the factor. That is why we are putting that item into that factor. The items are related with the factor. That is otherwise called loading. What is loading? The relationship between item and the factor, right? So between the groups, one group should not be related with the another group. Now let me perform correlation and I will show, right? So now correlation, right? Bivariate. See here, correlation is 0, no correlation at all. Significant value 1, not even greater than 0.05. It is 1, 100% no relation, right? So which means, right? Okay, so the factors are not related. Items are related with the factor. right? Very good. So now this is the one. This is the one. Sometimes, right? You can use this extracted score, this code, right? How to use, how to interpret, I will tell later, right? If you feel, right? If you feel these loading values or these extracted scores are not properly understandable, right? Then what you can do is you can use the mean score. You can use the mean score, how to put the mean, value, right? So now, for example, right? For example, item 1 and 4 and 5. These three are under group number 2, right? Now, right? So how to find out the, I'm going to get value for group 2. Another method. Now I have one method, right? There are many methods. So one method is, this is the score, right? This is the score for factor 1, factor 2, factor 3, right? So now I'm going to use another method to find out score for this factor 2, right? So now transform, compute, right? So F2, let me put F2 equal to, right? For what is these items? What are the items? 1, 4, 5. 1, 4, 5. So let me use 1, right? 1 plus, right? Plus 4 plus 4 plus 5, right? Plus 5. So 3 items. So I'm going to take average of these 3 because I know that these 3 items are loaded into factor 2. Okay, I'm going to find out the average. I'm going to place it, right? So now if I put it, I will get F2, right? If I go here, I will get F2, right? And so now this is the F2. Now I can understand. So a 5-point scale, so it is average. So what is this one? We can understand. So this also you can use. How to get this code, right? Only this one you should use feature, right? Suppose, right, if you have age category here, with that age category you can put ANOVA with this because this is a metric value. Please understand, since it is a mean value, it is a metric value. It is a metric data. When you have any categorical data, you can perform ANOVA, and you can find out whether each group is different with respect to that particular factor. That is called the ANOVA. Whether each group, right, 3 groups, whether they are different in this factor 2, like that you can understand, right? So this is about how to get this code. Now let me tell you quickly, right? Okay, so now let me take one more data, right? I will perform, right? So here it is, so this is only 8. So now let me delete last 2. This also I have to delete. Sorry. Right. So now, okay. So how to perform analyze, right? Analyze dimension reduction, right? So select all, right? Put it here, right? Now here descriptive KMO, right? So extraction 2, let it be values greater than 1, right? So rotation, we need to go for a very max rotation. Then we'll go for scores, right? Save these scores. then options sorted by size, okay, suppress, okay, all I am doing instead of performing one by one, I am doing all, right? Right. So now point one is right. Okay. So now it is okay. So it is greater than point 0.6. It is 0.731. So which means there is some data is adequate to perform correlation, and spotless text is it is significant, which means the correlation among the data is significant. So now okay. So now we say that. So it is divided into two groups, right? Two groups. So the total variance extracted is 52%. 52%, right? So now let us look at the okay. So now let us look at the okay first point. First. Okay. Right. So now, okay. So these are all the okay. So we will decide. These are all the statements loaded under group one. These are all the statements loaded under group two. Right. This is over. Right. This okay. You have this understanding. You have clearly. Right. Two groups. What are the statements loaded under group one? What are the statements loaded under group two? Right. Okay. Fine. Now you have a very clear understanding, right? So now right, let me go to okay, let me go to so let me not use suppress. Right. So now what I will get is right. So these are all the loadings. These are all the loadings, right, under factor 1. So these are all the loadings of factor 2, right? So now you watch all these things. Now I have PPT. Now I have PPT. I will go to this PPT and I will tell you. Okay. So now this is the okay. So this is the okay component matrix, right? This is the component matrix. Okay. So now these are all the component matrix loading, right? Component matrix loading, right? Now I told you what is the eigenvalue, right? This is before rotation. Before rotation, 0.530, 0.560. So these are all the loading under group one. So these are all the loading under group 2. Now square, and add. So this is the eigenvalue. Eigenvalue is nothing but sum of square, right? Squares. So squares, fine. All right. So now like that, okay. Now let us put okay, because let us put 8. Let us put 8. Okay, instead of 2, let us put 8. I will get this like this. Now add all, add all. So this is the eigenvalue for each group. Each group, right? What is this one? Okay, what are the items loaded under each group? Square summation, that is the eigenvalue. Now okay, for each okay, how what I have done is instead of putting 2, what I have put is okay, so what I have put is 8. Okay, 8 scores. Let me not save because every time it is saved. So I put 8 here. Why I am putting 8, you will now understand. Right. So now you will understand the okay. So 8. Okay. So come on, not transformation matrix. Come on, right. Component matrix. Right. So now this is the one, right. So this is the one I have taken. 0.530, 0.560, right? Okay, so squaring and adding. Okay, if you square and add, then I'll get eigenvalue of 2.5, 1.6. If add all, you will get 8. I told you, no, when you put total, it is 8. So total extraction, total eigenvalue is 8, right? So now this is the eigenvalue of this one. So this divided by 8, it is 0.325, right? 0.2, 0.1. So this is, so only two factors are more than 1. So that is why that is taken. Now look at this one, 0.32, 0.20. If you take 2 only, it will be 52. So that is what you are getting here. That is what you are getting when you put 2. When you put 2, what will happen? When you put 2, okay, so you will be getting, these are all the 2.5, 1.6, we might have noticed eigenvalues, right? So it will be, okay, so this is the 1, okay, so this is based on before rotation, 32, 20, 52. So these are all the eigenvalues. So what is eigenvalue is, right? What is eigenvalue is, right? So this is the loading squares and the summation, that is the eigenvalue. Now, if you put all, suppose 19 statement, 19 groups, totally if you add, it will be 19. It will be 19. So if someone is more than one, then something is will be, because 19 statement, each one, so 19. If one is more than one, some others will be definitely less than one. So which means variance extracted, total 8, this one extracted how much? That is called the variance extracted, right? That is one. Now, right. How I am getting this commonality? I have told you, know, how I am getting commonality, right? So now, right. So now look at here. So the first statement, okay. First statement is loaded, a component matrix. First statement is loaded in the factor 1 is 0.53, factor 2 is 0.449. So 0.53 square and plus a 0.449 square, right? So 0.53 square plus 0.44, if you put a square, that will go away. So 0.281 plus, so that is what the commonality. So commonality for each statement loading into this one, square and add. Okay, eigenvalue is particular group, all loaded, square and add, right? Very good. So, okay, so that is we have seen. Now, another one is, another table, what you will get is, right? Another table, what you will get is this, right? So, this component transformation matrix, right? So, this you will get. So, what is this? Now, you have component matrix, that is the before rotation. Now, after rotation, you have this one, right? How do you get? So, how component matrix transformed to rotated, that is shown in the, okay, so component transformation matrix. So now, okay, I will show here and I will multiply and I will show. Okay, so you will understand. Right. See here. So now first 0.53 square, right, here multiplication. All right. 0.53 square into 0.86 plus 0.449 into 0.592. So if we add, we will get this one, 0.86 added and so, right. So this is the component, this is the rotation. So this is into this one. So matrix multiplication, right. So go like this, come like this, right. So second one is this two multiplied with this one, right. So 0.53 square into 0.502, 0.499. So that will be this one, right. Like that. That is called the transformation. So now I think I've covered. Okay, so now this is what. Okay, so now okay, so now I will show on another, right, how it is grouping, right. I'll tell. Okay, so okay, the one simple data I will do. Okay, that will be I will take. No, I will not take. It is very big data. Uh, sorry. எத்தனை அதில் நினைச்சு அடிச்சு. Okay, so now I have this one, right. Let me use okay, let me use work environment and EI, right. So now analyze, let me use a limited data here. Okay, so that okay, you can understand how it is. So KMO, right, KMO, right. Then extraction, let it be rotation very max, right. Scores, let me not show. Sorted by size and suppress values greater than 1.5, right. Value greater than. Right. So now let me go to this output and I will show. So look at this one, 0.837, right? Very good KMO, right? Look at all commonalities. All commonalities are greater than 0.5, right? So now, okay, sorry. So it is two factors, right? Yes, I have put only 9. I should have put 10. I do not know why I have not put 1. Okay, let it be. No worry. So look at the rotated component matrix. Right. So all WE are one group, all EE are one group, right? Okay. So this is what it should be there. So now if you look at let us look at the correlation, then you will understand correlation, right? So now WE, okay. So right. So look at WE is look at the relationship. Okay, 0.9, 0.9, 0.8, right? 0.8. So it is having relationship with all the items, but it relationship with other items, right? Other items are less. So now what will happen is, so now see here 94999999, all are 97. So this will be in one group. So which means all W I, E is one group. Look at all the relation. So now if we come here, right? If you come here, right? All EI a relationship, right? So now all EI relationship, EI with EI. See here, all are high. But EI with others, it is less. So here, all relations. So based on relations only, it is grouping. Simple. Based on relations only, it is grouping. Right. So that's all about the factor analysis. Any doubt now? Any doubt on factor?
No, sir.
No, what? Madam Logeshwari, madam, clearly understood that?
Yes, sir. Somewhat trying to make it up, sir, with your materials.
What is the purpose of factor, madam? What we are performing factor, madam?
Grouping. For grouping. Grouping the
Grouping
statement.
of items, right? Grouping of items. So what we decide? We decide number of groups and what are the items to be placed under each group. Yes or no, madam?
Yes, sir. Yes, sir.
Okay. So how do you perform analysis?
Finding the sufficient correlation
No,
between
no. How to perform?
Analyze,
Analyze.
factor dimension reduction, then you can select, sir.
I don't know. Analyze, dimension reduction, factor. Analyze, dimension reduction, factor. Right.
Factor.
Under the factor, I have done many times. So descriptives, it will give KMO. All right. Extraction, how many factors to decide? Rotation, for the purpose of rotation. Scores, to save the scores. Option, to arrange, suppress the data and to arrange. Yes or no?
Yes, sir.
Right. Okay. So now with respect to extraction, total extraction, it should be more than 0.5, right? 0.5, at least 50%. Okay. So then like the same, the loading also, everything at least 50% we are interested, right? So that is why we are going for rotation and all. Right. Okay. Right. Is it okay?
So I think
Yes, sir.
Mr. Paul Kumar have some queries. He has raised hand, sir.
Yes, sir. Ask him to ask, madam.
Good evening, sir.
Good
Sir,
evening.
it was very good, very clear explanation, sir. I really appreciate. My query is, so factor analysis we do to make it a cluster and reduction in repetitive items to make it in a group. No, sir. So if we want to do in this, we got CFA and EFA. No, what?
No, madam, sir, don't go now, sir. So please try to understand what I am teaching, sir. I will come to that later, right? Let me
Okay,
not
sir.
tell
Okay,
that
sir.
now, sir.
Okay,
So
sir.
now try to understand what I am telling, right?
Okay, sir.
So now, sir, our objective is grouping of data based on similarity. Grouping of items. Please understand. It
Yes,
is
sir.
not clustering. Clustering is different. That I am going to tell there now.
Okay,
So
sir.
now it is grouping of statements, or
Okay.
otherwise grouping of variables based on similarity or based on correlation.
Okay, sir. Okay, sir.
So
Got it.
in that process, we will reduce the number of variable. 19 variable reduced to 4 variables.
Okay, sir.
So
Similar data.
Similar one. So items which are loaded, which are related to one group, right? Other items related another group, like that, right? So now this is what the exploratory factor. Exploratory factor, which means in the beginning we do not know whether there is any groups available, right? We have all the data and we are exploring whether there is any grouping is available, right?
Okay,
So
sir.
confirmatory factor, tomorrow I will take, right? This fact, by using this factor analysis I will perform, and there is another software by using Amos I will perform, right?
Okay,
That
sir.
is why I am not telling that both I will tell. Okay, so together tomorrow, right? Because that is very important. I will tell tomorrow, right? So
Sir,
now, if you have any other doubt, anybody, then otherwise I will go to cluster.
Sir, can I ask related to static, but out of this one question, sir, I have for many days I have this. You have taken the scale range, no, sir, in your this thing scales. This is one basic question, sir. How do you so for we know demographic we need to take a nominal this thing nominal scale kind of things. How do you choose for a particular? How do we come to know that this is the scale we need to choose? This basic thing I always get confused when choosing this.
No, sir. No, sir. You please try to tell your question again, sir.
How to choose?
Let it be basic, sir. No problem. Let it be basic. No worry about it, sir. No worry about it, right? So now you ask anything, okay, I will tell the answer. No problem.
Choosing the scale for the items, no, the things, no, sir. When we present the data scale, I get confused choosing ordinal, nominal, and the three type of scales. I get confused, sir.
Sir, that will take a lot of time to discuss, sir.
Okay,
but let me tell one thing, sir. Right? See, if you have age, that is a nominal data. For example, gender is a nominal data, sir.
Yes, sir.
It is a nominal scale, otherwise called a nominal scale or nominal data. Don't call it a scale. Okay, so then you will be confused. You call it as a nominal data.
Okay.
Then
sir.
if you have anything like age, right? Age 20 to 25, 20 to 30, 30 to 40, 55, 50 to 60, like that if you have given, then you will go for first, you will put 1, for second you will put 2, and then third you will put 3. For example, 20 to 30, you will put 1. 30 to 50, you will put 2. 50 to 60, you will put 3. Above 60, you will put it as 4. Then this is called the ordinal data. There is a order. Sir. Hello?
I'm listening, sir. I'm listening.
Now here we have used 5-point scale. Here we have used 5-point scale, sir. Hello?
Yes, sir. Yes, sir. Go ahead, sir.
This is the interval data, sir. Suppose if you have income, right? You have asked the income. You have put the dash, okay, which means you have asked the people to give their income 50,000, 60,000, 90,000, like that. If you have entered that data, that is called the ratio scale, sir. Right? Hello?
Yes, sir. Yes, sir. Yes, sir.
Now, okay. So don't worry about that, sir. Don't worry about that, right? Now here, we are trying to measure the perception, sir. Any perception, okay? So their opinion, okay, for which we use 5-point scale, sir. We use 5-point scale. You can use 7-point scale or you can use 9-point scale. That is up to you, sir. Right? That is one. So this is a interval data or the scale, otherwise called a scale. This is what we call it a scale, right?
Okay.
Though all are considered as a scale, don't call it all those two as a scale. That is a nominal data, that is ordinal data. This we call it as, though we call it as an interval data, but here we are using scale. Now, for example, you can see here, right? You can see here, see how I have performed, right? See here, this is a measure, right? Nominal, ordinal, scale, right? So these are all 5-point scale. So I have put a scale, right? Can you see, sir?
Yes,
right?
sir.
These are all 5-point scale. Now, what question you are asking is the another, not related to what we discussed today, right? That is a different one, right? That which means you require a very, very, very basic understanding, right?
Yes,
that's
sir.
fine. That I will take on some other day when I take in some other workshop. Tell me, sir. Now here, your question should have been, sir, you have put 19 statements. How you have taken 19 statements, sir? Right? So now there are many people, they might have used this variable, right? There are some 10 people, they do research for the development of scales. For example, if you take any psychological variable, already people have developed the scale. This is 5-point scale, right? The different item. So they have used, I'm also using.
I am also using. Otherwise, if the scales are not available, I can use my own scale. I can use my own statement. This is called a statement which are measured with the 5-point scale. 5-point scale. This we call it as a interval data set. This we call it as a interval data set. Is it okay, sir? Did you get anything, sir, or still you
No,
are?
no, sir. I got some clarity, sir. I need to
Okay.
work on that. I got some clarity. Thanks for the time, sir. Yes.
Okay, sir. So, any other question? Anybody? So, or otherwise,
Sir, this is for the benefit of researchers. How many number of statements should be minimum present in a scale, sir?
No, I don't understand, madam.
Now, in a scale, now this variable has got 19 set of questions now, sir. Is there any minimum number that one variable should have questions
Yeah,
under that?
yes, madam. So, now see that here we call it as one factor. Otherwise, we call it as one construct, right? Let us call with the name construct. So, each construct or domain or dimension. So, under which, okay, there is no hard and fast rule that you need to have only 3, you need to have only 4, you need to have 5, or you need to have 6. No hard and fast rule. That depends upon the variable or the domain which you are asking. See, for example, when you take a personality, you might be asking each and every aspect. You will be asking one question about each and every aspect. If that domain is having many attributes, then you need to put more. You need to put more, or otherwise, if the domain is having limited, you will be having less. But if you have more, then again you have to perform factor analysis. If you have less, then your Cronbach alpha value will be a problem. So normally we suggest people to go for 4, 5, 6. Right. So if you have this range, then you will not have any problem. You need not go for factor analysis. You can further factor analysis. Whatever construct you have used, you can use as it is. Hello,
Thank you,
madam.
sir. Thank you. Thank you for explaining, sir. Thank you.
Okay. So any other questions, sir? Okay. So then shall I go to cluster?
Yes, sir.
Yeah. Now cluster. Cluster also classification algorithm, right? But that classification is clustering. What do you mean by clustering? Grouping of respondents. Grouping of respondent, right? So respondent may be individual, respondent may be companies, respondent may be countries. That is not our problem, right? We say no, not our countries. We Asian countries, which means grouping of countries. So now we have textile cluster, which means all industries relating to textile, it is there, right? So clustering means grouping of the respondent, right? So how to perform, right? Now I have these 4 factors. All right. Now let me tell you, the 4-factor variables are metric variables. So the factor variables are metric variables, right? So these 4-factor are metric variables. So these are all, because these are all mean values, right? So these are all metric variable, right? So I can use it as for ANOVA and other purpose, right? Now I'm going to do, see, now I got this same, right? So like this, okay, so I used this mean, right? So this mean, same data, further I am going to use symbol. Same data I am going to use. But where I am going to start is, right. So now, sorry. So now do you remember, right? I have done a mean value, right, for factor 2, right? I got 4, 3, all these things, right? So now same thing, right? Same thing, right? Those 4 factors, right? So from 19 statements, I have reduced to 4 factors. So these are all the 4 reduced factors, right? I have told you that the factor analysis should not leave it. I have to use it further. Now, based on the factor variables, I'm going to group the respondent. That is, I'm going to perform cluster, right? So there is no necessity to perform factor before cluster. That is no compulsory, right? But after factor, you can perform. That is not. Without performing factor, straight away also you can perform cluster. No problem, right? Right. So now first one, let me perform through this factor score, right? So now first one, analyze, classify, K means cluster, right? K means cluster, right? So let me put all the very simple, right? Very simple technique, right? All the 4, all right? So otherwise, here I have taken factor scores. You can take any variable, right? You can take any variable, collector as it is, you can take. So now here we have to specify this is a K means cluster. If it is a K means cluster, you have to specify how many groups you want to. If it is a hierarchical cluster, there is no necessity. But if it is a K-means cluster, you have to tell how many clusters you want to have. So now, okay, so because normally cluster will be people, I will classify into low, minimum, medium, and high. So that is why every time I will be using 3. That is the point number 1. Point number 3, okay, so in future I will be using this correspondent analysis. I will be using discriminant and other things. In all these cases, if I have 3, minimum 3, right, then only I can use those things. So that is why I put 3 now, right? So now that is over, right? Now that is over, right? Right, fine. Right. So now, mm, see now, right. So first point. So it is having only 2 table, right? It is having 3 table, but okay, but only 2 table. That is simple tables, right? So now, okay, now here, first one, cluster 1, cluster 2. I have set 3 clusters, right? So now cluster 1, it has classified into 3 groups. So first group around 238 people are there. Second group 172 people are there. Third group 142 people are there. Then I am happy now, right? Suppose one group is around 500, around 400 people one group. Only 10 people in group 3. Then which means okay, it is not proper classification. One is very high, one is very less. So it is not good. Then I have to change the number of clusters. Now here, okay, so I have almost not very exactly equal, almost distribution is okay. I can be happy. I can be. So now it is, I have asked to divide into 3. Now it has divided. In which it has put cluster 1 238, cluster 2 172, cluster 3 142, right? So now, okay, that is the one. Now let me, okay, now let me classify. K means cluster. Oh, Already I have one variable, that variable, let me. Okay. So I have 4, right? Now analyze, classify, K means cluster, right? So 3 here, save, right? Save cluster membership. All right. Now, right. So now here, see here. Now this variable come. So which means, right? So it has put for person 1 in group 1, person 2 in group 3, person 3 in group 3. Right, this is the cluster classifying. So now we have divided the people into 3 groups, right? So this is a cluster, 3 groups. So it is a categorical variable which can be used for any chi-square for future purpose, right? So I said okay, so in this, right, so now I said okay, so 238 people. Let us see whether Q1 one is 238 too, right? So now let us see. Now let us see. Now let us see. This is the classification. Now let us see, right? Descriptive statistics, right? Frequency, right? So this cluster QCL means quick cluster, right? Frequency, right? Let us say, right? You can see cluster 1 is 238, cluster 2 is 172, cluster 3 is 140. So that is the first one, right? Now, right? Okay. So now second point, right? See, now he is in cluster 1. We have classified these people based on these 4. All right. So now we want to know what kind of people, placed in group 1, what kind of people placed in group 2, 3, group, like that, right? We want to know, right? Because we have classified how it has classified, right? So for that, so we have to look at this table. You have to look at this table. This is the that table. Now cluster 1 is having 238 people, right? So cluster 1 is having 238 people, right? So this is the variable 1, this is the variable 2, right? So variable 3, variable 4, right? Now let me please understand carefully. So this is the 1, 2, 3, 4, right? So these three I have 140 people. So for all 140 people, I have this code, right? So here, see here, let us take 2 here. Now for 2, here I have one value. For another 2, I have another value. I have to another value, like that. So for group 2, in the fact 1, there are many values. But here, I have only one value. For group 1, I have only one value. What is that value? That value is nothing but the mean value, right? So that is the mean value of 238 people for the factor 1. This is the mean value of 238 people for the factor 2, because so those many factor 2 will be there, right? So if you look at 3, so 238 people, 1 will be 238 people, 2 will be there, right? So that is the average. Now based on this, since it is average, we can understand. So now let us try to understand group 1 and group 2, group 3. All right. So now this is the mean value. Now from this we can understand group 1 is having higher mean value in all. Group 3 is having lower mean value. So these people, they have lesser value of all these things, right? So now I will these values, right? These values. Let me show 3.86 whether I am getting this one, right? So I'm going to get to the mean values, right? Don't worry about what I'm telling, what I'm doing, right? Okay. Okay. So in the fact one, right? Fact one. So one, right? It is 3.8. Look at this one. Fact one. Group one is mean value is 3.8, 3.6, right? Group two, right? 2.8, 3.8, 3.6, 2. Okay. So now let us go and see that. 3.8, 3.6, 2, 3, 2.8. Okay. So now look at this. 3.8, 3.6, 2.8. So that is the mean value, right? Very good, right? So now, okay, so now we have classified the people. That's all over, right? So when you ask to save, it will give, okay, it will save. So that can be used for further analysis by using chi-square because it is a categorical variable. Categorical variable. Now here, what is required is we need to give the name for each group. There we have done a name for each factor. Now we are going to give name for each group of people, right? So now when you are giving a name, it should represent a people, right? Okay, so for a saver, motivator, because it should, the word which you are using, it should give represent the people, right? So motivator, thinkers, like that. It is not factor, it is a cluster, right? So now we know that the first cluster people, they have high value in all, which means in an investment, so they consider all the criteria. That is the meaning. They consider criteria one, that is a convenience. Criteria two, which is a risk protection. Criteria three, which is a return. Criteria four, which is a liquidity. So they have all high values, which means they consider. Low value means they are not considering, they are not using. High value means they are considering, right? So which means they are considering all the factors before taking an investment decision. Such people, we call them as rational investors. Rational investors, right? So category 3, all values are less values. Apart from that, less than 3, right? In a 5-point scale, less than 3, which means they are not considering. Who will not consider? Just like that, they will make any investment decision. They will not consider anything. They will just like that, they take investment decision. They are called the irrational investors. So group 3 is a irrational investor. Group 2 is a normal investors because they use the risk. They use the risk. They consider convenient. So certain they consider, certain things they don't consider. They are normal people. They will not consider all. Whatever they feel like important, they are considering and they are leaving. So they are normal investors. So you have to give a name for each type of group. So as soon as the name is given, right, here you have to enter, right? So now when it is classifying, it will not give any name, right? So here, right, here you have to take one is called the rational investor. Okay, rational. So rational investor, right? So add 2 is called the normal investor. Right. 3 is called irrational investor. Right. Rational investor, right? So now we have given the names. So here also I can give. Okay, so these investors, what is the base? That is a criteria-based cluster. Right? So I can take criteria-based here also. So this is a cluster based on. Okay, so this is a criteria cluster. Criteria cluster. So under criteria cluster, I have three clusters. Yeah, three clusters. So I have saved. So this can be used for further analysis. So now what happened? 19 statements grouped into 4 factors. Based on 4 factors, it is converted into only one variable. See here, now only one. So this is based on these 4, right? This one we have not done just like that. Based on this 4 is based on 19. So 19 is converted into only one variable. So when you have a cluster, you can do fantastic analysis. Like okay, so whenever you have any metric variable, you can perform ANOVA. Whenever you have another categorical variable like age, right? So which age category people belong to, whether high, whether low age people, whether they are rational investor, whether they are irrational investor, which people are rational, which people are irrational. That you can find out by using chi-square test. Right. So now this is the one. Right. Now here, right, now this is based on factor, right? So now without having factor also, right, for example, right, see here, these are all the statements, straightaway 6 statements, right? That is for one domain, one construct I have put. Okay, so 6 statements, right? So under that domain, I can classify in that domain what are the different clusters are there, what kind of people are there, right? So now here this also can be used, right? So classify, right? Classify K-means cluster, right? Save, right? Cluster membership, right? Now I got it. So now I have a new cluster, right? Now this is cluster 2, this is cluster 3, like that. So now you can go and see. Based on 3 they have done this one. Now you can see, right? See here only 25, right? 8 people, 1, 2 people is 10, right? 7, right? Okay. So now if you look at it, right? So now here, right? This among this, right, V5 is having higher value. So the group 1 is V having higher V5 characteristics, right? V5 characteristic. What is V5? Let us see what is V5. V5 is right, what kind of people? So V5 is I buy only daily need products in a shopping complex, right? So everyday need products only they will buy. Okay, so that kind of people. So next is okay, cluster 2. Okay, so they have V1 and V2. They have these characteristics as well as this characteristics. So V3 they have V2 and V3, V4 and V6. So other 3, right? So based on these 3, you have to give some name, right? So these are all the one, right? So now okay, so now the question is, there is a big question: how to decide this number of clusters? Right? So now So now let me go here. There are many, again, there are many techniques. There are many techniques, right? Analyze, classify. There is one thing called a two-step cluster, right? Two-step cluster, where let me put all the four, right? All the four are continuous variable, not categorical variable. So let me say, okay. So maximum, I'm asking 15 cluster, right? So you decide on your own. You tell how many clusters it can be done. So now it will tell, right? It will tell, right? So it can be classified into two clusters. If you divide two clusters, it is fine, right? So if you divide in two clusters, right, so it is fair. It is not poor, it is okay. Fair is okay. So getting good is very difficult, right? So, okay, so two cluster is sufficient. Two cluster is sufficient. So now we have done now reason one, right? Now what to do with this, right? Two-step cluster, right? Okay, so classify two-step cluster. Right, all are continuous variable, right? We'll say here, right? You go here and right, you go and see the output, right? So now here, two-step cluster, it says only one cluster is sufficient. You need not go for cluster at all. All are one group. You can put all are one group, right? So, but if you want to have two, three, that up to you. You can decide that your convenience, right? So, based on the data, what it is, that is one, right? So, there is one more thing called hierarchical clustering. Right? Classify to hierarchical clustering, right? So, now let me put all these six, right? Let me not have this one. So statistics, okay. So method, all right. I'm using word method. Continue. Okay. So now, okay. So now here, you look at these. Okay. Here, right? Coefficient. So now it says, right? If you have, right? So now, if you have only one clusters, if you have 25 clusters, what will happen, right? Starting with the 25, reducing one, right? So the coefficient, if you have only one clusters, right, it is this one, right? Slightly increasing here, increasing here, increasing. So only here there is a sharp increase. So that is why it says it can be classified into only one. So now let us perform with the another. Let me with the this okay. So it will take a lot of time. That is why normally I will not perform hierarchical cluster, right, with a large number of data. Word method, okay, so it will be little faster. So now look at this one, right? So coefficient all 0, 0, 0, right? All 0, 0, right? All 0. All 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Now you say, okay. Now if you see here, right? 0, 0, 0, 552 only. Now it is 1, 2, 3, 4, 5, 6, 7, 10, 20, 30, 40, 50, right? 100, 200, 300, 400, so 500, right? Right. So now 500. Sorry. Two more are there, right? It is down. Okay. So,
Okay, so now, okay, see here. So 400, 500, 600. So here from 600 to 900. So you can have 1, 2 like that. Okay, so we need not have many. So like that it is telling. Suppose from here, okay, it reached here 400, straight away 700. Then you have to put 552. That is the total sample. Total sample, right? If it is sharp bend, that is called elbow. So when there is a sharp rise, so that is a bend. So if there is a bend here, 552 minus 449, that is the number of clusters. So here there is a sharp rise here. So that is why we say 552 minus 1 or 2 we can have, right? So that is what number of clusters. But what I feel is based on convenience. So based on whether the item, the number of people under each cluster is okay, then okay. So if you adopt that, that will be better. That will be better. So which will be more suitable for your analysis. So that way you can use, right? I can put the stream matrix, but it is not coming, right? That is about the cluster. That is about the cluster. But one thing is, right? One thing is when your data is, please understand, when your data is, right, all 5-point scale you can perform. If some data 5-point scale, some data 7-point scale, some data total ratio scale, you should not perform correlation because it is performed based on the distance, right? So now what will happen? So all are plotted. For example, variable taken, all are plotted. So there will be centroid from that. So it is calculating distance, right? It is calculating distance, right? Say from the center. Okay, if you put 3 centroid, it will create 3 center. From there, it will find out distance, right? Whichever is having less distance, it will place on that group, right? So now, if you put one variable with metric value which are in 1000, the mean value will be in 1000. So that from that distance will be very high. So all the variable, all the grouping will be done based on that variable alone. So the condition is when you want to perform cluster, all the variable are in the same scale. You should not have, right? You should not have any other high value items. You should not have any other high value items, right? Okay, so that is the important one you need to know in the cluster, right? Then what else? Okay. One thing I want to tell, I have forgotten. Number of clusters, we have seen this, we have naming clusters, cluster membership. It is a one more, right? Okay, fine. So this I have forgotten, right? I will tell you. Right. So now we have done cluster based on this 4. Now I want to know whether we have used all the 4 variables, right? All, whether these classification done based on only, see, I've told you, when you put any high metric variable, all classification will be done based on only that variable because the distance between each variable, each item will be more on that variable, right? So now K means cluster, the options, right? We have used to save here options. So if you use this ANOVA table, right? If you use this ANOVA table, then you can understand this. Okay, then you will get ANOVA table here. So this is the ANOVA table. Now all are significant. So which means, right? So the groupings are done, classifications are done by using all the 4, right? Otherwise, each group, they are different, right? In each variable, right? So they are different. So this is making difference in that group. So otherwise that group 3, right? So group 1 is different from all other 2 people in factor 1.
They are different in factor 2, they are different in factor 3, they are different in factor 4. So that is why all the 4 are used, are making distinction, are used in making classification. This table you can report, right? So how? Okay, so if you understand ANOVA, you can understand. Otherwise, let me tell in a normal meaning, right? We use all the variable to make this cluster. All are making significant contribution for classification. This is one side. Another side, each group is different in all the factors. Right. So this is about the clusters. This is about the cluster. Very simple, right? It a classification of respondent. Number 1. Number 2, from the factor variable you can perform. Otherwise, straight away from the collected data you can perform. Right. Now, it will tell how many how many people are under each cluster. That is one. Then it will give the for each cluster, each group, right? So what is the mean value for each factor, right? Mean each group, mean value for this factor, mean value for this factor, mean value for, so if you have used 5 factors, right, it will give mean value or not. So we can understand, okay, whether they have higher mean, which means if they have higher mean, so they possess that character. They possess. If they have lower mean, which means they do not possess that character, right? So based on this, we can identify the characteristics of each cluster, right? Then we use ANOVA to find out whether each is making a significant contribution for classification. Then you should consider this as a categorical variable, right? So when I say categorical variable, you should understand when for between 2 categorical variable you can perform the I-square, right? Okay, so then so when you want to perform cluster, all the variable should be of same nature. 5 point scale, 7 point. You cannot use 1 7-point scale, 1 5-point scale, you cannot. So this is with respect to clusters. Now if you have any question, you can ask me now. Madam.
Sir, I have a question, sir.
Yes, madam. Yes.
How about the interpretation part, sir, for both analysis, for cluster and for factor? How to write interpretation, sir?
That is what I was
Now
telling
you
for every time.
about ANOVA, it was very clear, sir. If at all for grouping, you're talking about grouping of respondents, right? How to do that interpretation alone, sir?
No, madam. That is what for each table I have given explanation or not.
There's any prescribed format for writing this interpretation or?
No format, madam. No format.
Okay.
Right. So whatever I have discussed by using each table, I am describing each table, madam. Right. See, for example, right, KMO. What is KMO? See, let me read. Okay, so for factor analysis, right, let me read. Okay, whether I have sent that to you or not. Okay. Right, factor. The interpretation is not separate one, madam. It is whatever we have discussed, that is the interpretation, madam. Anyhow, okay, since you have asked this question, let me tell. Okay, so now this is the data. Okay, with working place condition, right? I have asked the migrant laborers about where they are working, workplace conditions, right? Okay, so now. So okay, so now I've used how many statements? I used 13 statements. 13 statements. Regarding workplace condition, I receive adequate support from my boss superior. I receive adequate support from my co-workers. Okay. The safety measures is okay. So working hours is okay. Sufficient break, sufficient training, sufficient water facilities, right? Like that. Okay. So okay. So these are all the 13 statements. Now these are all the mean values. What is the interpretation for mean value? It is written, right? It is written. It is written. So now first one is KMO. So KMO, right? This is the KMO table. Factor analysis is used to group the items or variable or statements. The grouping is done based on the relationship that exists between them. Simply, the factor analysis is the factor in factor analysis. The related items are grouped and called a factor. Every item might be having some relationship with the other item. KMO is the overall relationship for the matrix. That is all. Here, the overall relationship, the otherwise KMO should be sufficient to perform factor analysis. This is otherwise called measures of sampling adequacy. If the KMO is greater than 0.6, then MSA is adequate to perform factor analysis. Here KMO is 0.799, which means the sample is having adequate correlation to perform factor analysis. Another test of sampling adequacy is spotless test, which tests the null hypothesis as all diagonal values are not zero. Since the requirement is high correlation, null hypothesis should be rejected. Here high square value is this one and the significant value is this one. Both the statistics indicate that sufficiency indicate the sufficiency of correlation in the matrix to perform factor analysis, right? Then variance extracted, right? So here 13 statements are used for factor analysis. Reduce 13 statements into 4 factors. The extraction method used is principal compound. Factors are decided based on eigenvalues. So whatever I have discussed, I have written. Hello, madam.
Same to same. கவலையே இல்லாமல் வாழ்வதற்கான வழி மாறுகிறது. மேக்ஸ் பூபாவின் புதிய அவதாரத்துடன் நீவா பூபா
We'll follow this.
Anything different, madam?
No, sir.
Right. So this is what I have written. Madam. So right, a commonality table. Commonality should be okay. So more than 4.5. So here all are greater than this one. So all these statements are properly extracted. So rotated. So these are all the statements grouped under 1. These are all the correlation grouped under 2. These are right. So then factor naming, right? Factor naming each factor. Then again I put mean, right? Each one separately. I given first one is some name. What is the name of this one? Vacation and visit to native. That is the first factor name. Second factor name basic amenities. Third factor name is hazardous work. Fourth factor name is okay, something I left. So these are all the 4 mean for that one, the mode for this one. So further analysis I have done like that. Okay, it is going on, right? So this now today it is not coming. That is why I am not sold. So this is the how to decide, right? Here there is a big bend. So I have used this one, right? Algorithmization table in a graph form. This is dendrogram, how to decide by using dendrogram, right? So I am not
online panel
this one.
discussions
So
on
this
past
is
and
the
workplace
factor
in
score,
association
right?
with
This
the
is
Indian
the
Lawyer
score.
Association.
So based on that, I have given a name for the cluster. Factor, then cluster. This is the ANOVA table for the cluster. Number of cases.
But I think Smita has gained enough ally
madam?
expertise to talk about it. And
It is very clear.
she has been
We had a
constructive
question in the group, so that
So
that one
when
only
we are
Lokesh
addressing the
posted.
new
So it is
No
very clear,
problem, no
sir.
problem. See, every time after hearing so much interpretation, finally, every time, this is not the first time. Right?
I understand, sir.
So they thought I am talking something different. Then finally, hey, sir, what is interpretation, sir? Right? I will share this also, madam. I think I have shared. Otherwise,
Yes, sir, you have shared. You have
I
shared
will
one
share
time
this also. You can see how I have written interpretation. Factor.
Thank you, sir.
Both
Excellent,
factor
excellent.
cluster, written. So how I have done this chi-square also with the cluster, that is also written, madam. I will give it to you, madam.
Yes, sir.
Okay. Any other doubt, madam? Now, if you have anything, you ask me. Then only so some myths, some understanding you will be having on your own. So that will be clear. So if you don't ask that myth, you will try to carry all along.
Dear participants, now the session is open for Q&A. If you have some valid questions, please go on. Vishnupriya, do you see any questions in the chat box?
No, ma'am. Actually, there's no questions, ma'am.
Can you just read out the comments from the chat box to sir?
Yes, ma'am. Sumati M has most of them have said thank you, sir, and it's a very informative session, sir. They actually loved the session, sir.
No. See, that anyone can write, madam. See, without listening also they can tell a good session, right? Very informative. Okay, but if they tell, sir, this is okay. So this I have understood from your discussion today. Okay, so that will be better, right? If they
Yes,
put,
sir. We will send an Google feedback form so that we can collect that information.
this I have learned today, sir. If they say that, that is the feedback. That is the feedback.
Okay, sir. Okay, sir.
Anything else? If there is no more question, which means we can close, madam.
Yes, sir. Yes, sir. Vishnupriya, please render the vote of thanks.
Yes, ma'am. Yes, ma'am.
Yeah, you can ask some of the participants to say vote of thanks, madam.
Sir,
Okay.
actually,
Okay, sir.
Why do you disturb
actually,
this?
a participant has asked to share your contact number, sir.
Yeah, we will share it at the end of 5 days FDP, everybody's mail ID with their permission. Vishnu, ask somebody if they can give the vote of thanks from the participants.
If they are not giving, then Vishnu Priya madam can give.
Okay, participants, if anyone is interested in giving
But
opinion,
I will not leave you. I will come the day after tomorrow also.
Yes, sure, sir.
please, anyone can share your thoughts about how sir did.
Okay, otherwise,
Sir, good evening, sir.
yes, madam. Yes.
Sir, I'm Prabha from Coimbatore. I would like to share my thanks to you, sir, because it is really wonderful and very informative session, which I was learned something from new from you, sir. So
Yes.
I
Yes.
want to thank you so much for your opinions and your topics. Anything which is you are providing on the screen is also very, very, very informative for me. So thank you so much, sir.
Okay. Thank you, madam. Thank you, madam. Thank you. Thank you. So, Vishnu Priya, madam, we can close. Logeshwari, madam, we can close, madam. Okay, thank you.
Thank
Yes,
you,
sir. Thank you.
so
Thank you
much.
so much for your time, sir. Thank you.
Okay,
Thank you, sir.
Thank you. We'll meet Thursday.
Thank you.
Yes, sir.
Thank you, Lokeshwari.
Thank you, ma'am.